of the big names like Jordan Peterson,
Of
who's
course.
now posting like toy state. I don't understand. So this is a weird thing that I don't understand with him.
You are confronted with a climate skeptic, okay? And your whole family is watching, and they're all going to become climate change deniers if you can't make a compelling case for your side of the argument. What are like 3 things that you bring up, or like 2 to 3 things where you're like, these are the things that I would point to be like,
Hello.
hey, how's it going?
You can hear me good?
Yeah, can you hear me?
Good. Yeah. Thanks for meeting. I can.
Yeah, I can hear the spaceships in the background.
That's yeah. Yeah. So
Hold
this
on.
is
Let me get your video on stream. I'm live, so don't say anything too crazy, okay?
okay.
Boom, boom. Real quick, do you want to introduce yourself to everybody so everybody knows who you are?
Yeah. So I'm Chris. I am a climate and planetary scientist at a NASA branch in New York City, NASA Goddard Institute for Space Studies. It's mostly an Earth science division. We have a small group of people who do modeling of planetary atmospheres as well, a lot of theory, and it's also I don't work on this, but it's also the place that produces one of the major global temperature records. So when you hear 2020 warmest year on record, that kind of stuff, that data is coming from one of a few institutions, including the one I'm at. So yeah, that's
Gotcha.
me in a nutshell.
What prompted you to reach out to me?
Oh yeah. So I guess I saw your thing.
Also, wait,
With
real quick, just to improve the quality of this, because there is a lot of background noise. Is it like an air conditioner or a fan or something near the microphone, or?
darn, there's yeah there is a ventilation thing. I can't do anything about it though.
On a Discord on the bottom left, next to
Yep.
are you using the application, the program, or are you using the web thing?
I'm using the web thing.
Is there
So I see it.
a noise
See
suppression
user
thing?
settings.
Next to the
Sure.
disconnect on the actual program, there's like a noise suppression thing. I don't know if that's on the web program though.
Deafen. I think that just mutes me.
Okay, gotcha. All right, it's not a huge deal. It sounds a little bit like you're in a tunnel chamber, but okay. Sorry, you want to repeat your? Yeah, what was your? No, go ahead. Yeah, what prompted you to reach out? Yeah.
Yeah, so I saw you were on you do a bunch of things. It's kind of cool. I'm pretty new to this like seeing streams, and so I saw I saw the one with Michael Schellenberger, and you seem to be there was a panel, and you seem to be the only one that had a curious mind to like ask him about the graphs he was showing. So I was like, okay, that's cool. And I saw a lot of other videos, and actually this whole community is fascinating. So you do politics, relationships. Like I've seen a bunch of different themes. So you're kind of all over the place. Also, you're gaming at the same time. What draws in most of your audience?
I would say I'd very roughly say like politics, I guess. But I mean like that's like saying like philosophy, right? Like it could mean anything. But I think like broadly speaking, I'm kind of like a center left to far left person, depending on how you view it. So we talk about like a whole bunch of things that intersect with politics. So politically, we might talk about like things like the government. But if you get into things like Donald Trump, you're probably also getting into like conservative social thought, and then from there you're getting into conversations about like abortion or gender roles, and then from there you're getting into things like the red pill community and everything. So yeah, just kind of like it branches out all over the place based on what my interests are and I guess what my audience is interested in, and then what the hot topics are in pop culture. So the Andrew Tate stuff has been driving a lot of the red pill and relationship type conversations recently.
I think that would frustrate the hell out of me. What is that like a biggest source of? Because I see sometimes you talk with these people, and like you have a very aggressive personality, which is
Sometimes
probably good for that kind of a crowd, because they like to take over debates by like brute force, and if it's rare someone can like combat that rather than just like, oh no, you're mean, so I'm gonna go away.
Yeah, I think that's probably been the biggest reason for my success, because I'm usually willing to. My background is very aggressive. I'm like a permanently online like shit talker, evil person or whatever. But I'm like left leaning, so it equips me to kind of like deal with some of the more aggressive right leaning people. So my biggest asset is I'm willing to usually talk to or hash out anything with anybody online. And for a lot of center left or far left people, they usually don't want to engage in conversations with those people. So yeah, that's definitely been my biggest asset, I would say.
Yeah. I think we share that in common, but I don't really, I'm not in this in this universe,
Sure.
but it's pretty cool. Anyway, so yeah, that's why initially, like, I was like, oh yeah, this person has a lot of viewers, and they you seemed to care and at least have the curiosity to challenge someone. So at the same time, there's been like, I don't know, on Twitter, if you're following Twitter actively,
Unfortunately,
there seems
I
to
do,
be,
yeah.
there seems to be a lot more interest in climate from some of the big names like Jordan Peterson, who's now posting like twice daily. I don't understand. So this is a weird thing that I don't understand with him. Jordan Peterson, I've always found like, not my cup of tea, but not someone that's like maliciously just throwing out disinformation. But he is with climate. And I think he's a little interesting when it comes to psychology and just like talking to people and advice. I think some of, at least 5-6 years ago, I think some of the criticism against him was like partly justified, but a little over the top for no good reason. But now I think he's kind of entered conspiracy land, and there's this kind of whole camp of people who seem to just be contrarian for the sake of being contrarian, and it doesn't
Not
really matter.
Not necessarily contrarian. I understand why it would feel that way, especially if because I mean you are the establishment. So to you everything's going to feel very contrarian. But yeah, there's definitely been a bend since Trump, and then COVID hyper accelerated this trend to where traditionally we're used to seeing this left and right paradigm for politics. It's just kind of how we view things, maybe even all over the world to some extent, this left-right thing. But I think when populists start to become popular, I think that the paradigm starts to shift a little bit to establishment versus anti-establishment. And right now, it happens a little bit on the left, but on the right, there are huge drives that are anti-establishment. So if you're part of the establishment, it's going to feel contrarian because their takes are literally going to be whatever is against the establishment. So you can publish 50 papers in the Lancet, the New England Journal of Medicine, and everything, showing that COVID vaccines are safe, but like one Medveer fucking preprint that goes up saying that like eating ivermectin will cure you and mRNA vaccines change your DNA, turn you into like pigs, like that gets all the traction because they want the anti-establishment take. And then the same is going to be true for climate science as well, although climate science has a couple of unique problems related to it, but yeah.
Yeah, so that seems to be my thing is like, and the other thing is there's no, when I take like a zoomed out, forest for the trees perspective about this kind of, shadow network, contrarian, like Brett Weinstein, Jordan Peterson camp of people who are skeptical of the establishment. I don't think anyone serious would be like everything went perfect for, there during COVID lockdowns, or in the case of climate science, we have a lot of people who are like, throwing paint and shit at art and tying themselves down to highways, which is pretty cringe, and I kind of don't think people should do that. But at the same time, I don't know that this is that big of a deal. And also, at some point, if you're going to be skeptical of this stuff, you also kind of need to produce your own ideas that are not just obviously wrong, like ivermectin or hydrochloroquine. So they're not actually contributing to the body of knowledge on whether it's COVID or climate or I guess evolutionary biology used to be a thing. That,
it still is in the Evo Psych is a big thing now in the red pill spaces. I agree with you 1,000,000%. The problem is that like they ask so many, when these people are skeptical, they say things that are really good, but they don't do any of them. Like here's something that I know for a fact. Anytime somebody comes up to me, they're like, "Oh, like you should do your own research." They don't. They don't do their own research. Like when you're saying like do your own research, oh cool. So like what papers are you going through? Like who are you looking towards? Like how are you investigating things if you're doing your own research? And it's always like, well, I listened to a podcast with Tim Pool or Joe Rogan or Jordan Peterson or Ben Shapiro, and they said this. Like, okay, so you don't do your own research, right? You just like blindly follow whatever alternative media YouTuber you have, and it's so frustrating because I do agree with you. Like skepticism is really good, and people fuck up, including the establishment. Unless this is bullshit, I'm pretty sure there was like a fucking was it a NASA rover that crashed on landing because they used like metric and imperial like interchangeably, and it fucked up the. Do you know what I'm talking about?
I do. I have to look up the exact rover because
Yeah.
I should probably know this offhand, but I don't.
Yeah, but I mean, like,
but
yeah,
yeah,
like
that
people
was the
fuck
thing
up.
that happened.
Yeah, people fuck up, and it's good to hold the establishment like, hey, like you need to answer for these, or you need to respond to these criticisms. But yeah, people just veer off into some crazy fucking territory with no research or data backing it. And it's like you're not helping anything. Yeah.
Yeah. I will say with climate science in particular, it's kind of interesting the evolution of, let's say, advocacy or and I could see why some of it's off-putting. So I started I started in, back when blogs were a thing. There were a lot of blogs talking sort of about the physics of climate, how the greenhouse effect works, and how how to kind of bridging the gap. There needed to be a bridge gap between, like a Wikipedia entry and the peer-reviewed literature, because there were a lot of people interested in things that were more technical but didn't want to read journal articles. And so the blog space got filled up, and that was good. And then social media came around after that, Twitter, and so a lot of scientists went on Twitter, and we could share our 140 character bites about the most recent paper. There has been so the new, I guess, advocacy around climate of kind of doomerism, which is a thing. It is something that don't fly because you don't have kids, that kind of stuff. I think that message, it's coming from a small number of people, but it seems to have reached enough people that are annoyed about it.
Yeah.
So I do sympathize with people who are frustrated with that sort of messaging. I find it ridiculously cringe, and there's no evidence it works, to be honest. But also, it's just it's usually misplaced too from a technical standpoint. It's like not flying or not having kids. It's kind of a small potatoes when you like break down the actual numbers of what that's supposed to do to climate. But anyway, yeah. So I guess what are people curious about, like how climate change works, or
Yeah, if you want, I feel like everybody, I feel like the people that know, and the people that don't know don't care. So there's no modeling, like, or you could talk about like different greenhouse gases or melting of ice caps or different forms of like natural carbon capture. But like if you're a climate skeptic, I don't know how many minds you're ever like changing by explaining some process. We can walk through that at some point if you want, in terms of like talking about things. Like I'm always interested in more information. Before we hop into that, I guess something I'm curious about, if you're confronted with a climate skeptic, okay, and your whole family is watching and they're all going to become climate change deniers if you can't make a compelling case for your side of the argument, what are like 3 things that you bring up, or like 2 to 3 things where you're like, these are the things that I would point to be like, hey, holy there's a problem, like look at this. And then I can tell you a couple of mine after, because I'm just curious what your things are.
Yeah, so I mean, so the first thing is the physics that kind of determines, why it's getting warmer is very well established. It's about a century old, at least, depending on kind of what you count as the initial start date of the stuff. But so we know how CO2 warms the planet. It's basic radiative transfer that applies not just to modern climate change, but also to past climates on Earth. People point out frequently to us, as if we don't know, that there were periods in Earth's past, much of Earth's past, in fact, that had higher CO2 and hotter temperatures, which is true, and that's
Can I? So in the interest of being really fair, so I'm going to push on some things because making measured takes, I think, is good for everybody. How reliable is it to measure like what average surface temps were like in the 1500s, 1600s, 1700s? Like I'm curious, what is the process for that? I understand like radiocarbon dating for age and like different isotopes for carbon, but I don't understand the temperature measuring. Could you explain that?
All right, so depending on the time scale, so you asked about a few hundred years ago. So for that, so there's different what we call proxies, which are things that sort of know about temperature, but that aren't directly temperature. So it's not a network of thermometers, obviously, in the 1300s, but networks of what we call proxies, so tree rings or things like that.
Sure.
As you and the relevant proxy you would be interested in depends on the time period. So you could look at ice core records that in Antarctica go back almost 1 million years for atmospheric composition, for example. Tree rings go back hundreds to what's the oldest trees, a couple thousand or something. But lakes, things like lake sediments, and then as you go to deeper time, so you're interested in ocean sediments that these things called foraminifera that measure the isotopic composition of seawater, which depend on a few things. It could depend on the ice volume on the planet and a direct temperature effect as well. So those would be some of your main methods, and then people, there's exhaustive inventories of thousands of proxy networks that people spend their careers synthesizing and time dating and calibrating and testing the methods to understanding the relationship with temperature or whatever climate. Not every proxy is a temperature proxy. Some are precipitation proxies, such as certain tropical cave isotopic records and caves that care about precipitation amount, things like that.
Okay, let me try to simplify that so that everybody understands, or make sure that I understand too, when you say this. So essentially, there's a bunch of things that will happen in different domains of science given a certain temperature. So like maybe it'll be like the distance between two rings in a tree in an ideal climate will be 2 inches, but like in a climate where it's far too hot, it'll maybe be 1 inch, or in a climate where it's far too cold, maybe the rings will be uneven because it grows unhealthy. So that's just a hypothetical I make up. But ideally, you've got these different domains of science that see different things happen at different temperatures, and assuming you can date something accurately, seeing the variation in the environment of all these things allows you to kind of get a proxy for what the approximate temperature was at that point in history, and then hopefully all of these different domains kind of agree on what they see, basically.
Sure, and some of it is so the tree ring width or density is a good example, and then there's isotopic based records, which are sort of based like, so people know that oxygen has different isotopes, and so there are effects with temperature, for example, that will change the ratio of those things.
Gotcha.
There are same thing with ocean sediments. And yeah, so there's if you were to do like a paleoclimatology 101 class, the class would be kind of covering the strengths and limitations of dozens of different such records. But
Okay.
we and then of course there's just evidence for example, if you were to go back tens of millions of years, you get into these hothouse climates. Where we know that there's no ice sheets on the planet. There's, in some cases, tropical like fauna at the poles, and so those are preserved, things geologically.
When you
And also period.
or no, go ahead, finish that.
Yeah, go ahead.
Well, I was going to say, when you bring up that there has been wild variation of climate in the past, oftentimes one of the most common responses from people skeptical of climate change is they'll bring up that, like, well, actually, we've been through ice ages, we've been through times where the climate has been significantly warmer, and all of that happened absent any human intervention. So how can you claim anthropogenically driven climate change now when the climate has been much warmer in the past without any anthropogenic causes because humans didn't exist or weren't polluting?
Sure. So I guess there's a few different levels. I mean, the first one is I just try to show the fallacious part of the argument, which is, like a lightning can strike a fire and or strike a forest and cause a fire, but that doesn't mean arsonists don't exist. So
Sure.
that's just pointing out the logical part. But then the scientific part of it, which is probably most interesting to people, is that climate doesn't just get up and change on its own. There are causes for climate change. And so if you were to run 4 billion years of Earth's history with nothing about the sun is changing, volcanoes aren't going off, there's no changes in the orbit, there's no changes in mountains going up and down, climate wouldn't really, there's no reason for it to change. It would vary just in the fact that the ocean and atmosphere are fluids that are sloshing around and redistributing heat in interesting ways. That we have El Nino site, things like that. But that's just variability on these sort of time scales of decadal, and so the time scales of the atmosphere and the ocean to move heat around. But when you're talking about ice ages that are tens to hundreds of thousands of years, those are caused for a reason. Those are principally caused by changes in the Earth's orbit, how tilted it is on its axis. I think most people know that we have seasons because the Earth is tilted by about 23 degrees on its axis, but that varies between 22 and 25 or something like that, and how oval shaped the orbit is. And people have played with those things that what are those those caps that wobble around when you do it. That's called precession, which is just how. So even if you keep the tilt the same at 23 degrees, it can precess, and so now it's facing. It's summer at a different point in the orbit, so it changes the timing of the seasons.
Gotcha.
Things like that. So that is, and ultimately those things can change the seasonal distribution of radiation, especially at the poles, and so that can promote or inhibit ice sheet growth at the poles, and that can trigger ice ages. But those orbital things, and there's also greenhouse gas feedbacks during the ice age cycles that you actually need to get the full amplitude of an ice age, and to also synchronize it globally so that the north and the south and the tropics are cooling and warming sort of together.
Okay.
But that's tens to hundreds of thousands of years. Now, when you go to geologic time scales, like many millions of years, we're now thinking about changes in the distribution of continents, the uplift of mountains, and a lot of that, the carbon cycle is particularly affected by that. And so if you were to look at CO2 concentrations, say in the last 50 million years, you see a gradual trend downward. And so those high CO2 concentrations are periods of hothouse climates where there's no permanent ice, either in both hemispheres, or in some case, Antarctica sort of formed first, and then Greenland. And yeah, so it's perfectly consistent with our expectations that higher CO2 causes a warmer planet. And when you look geologically, CO2 really is sort of the control knob on climate, but on orbital timescales it's different. So this time around, it's just been a century where humans are the ones putting the CO2 into the atmosphere quite rapidly, and it doesn't really matter whether it's coming from fossil fuels or from some crazy volcanic eruption or something like that. Once the CO2 is in the atmosphere, it causes warming.
Gotcha. So the short answer of that is essentially, if somebody's claiming temperatures or climate has varied throughout human history, so that's just happening now, then you would say that yes, climate has varied, but it's been for particular reasons, not just randomly. So if you're going to point to something, you need to show the mechanism by which is causing the climate to change, and then explain how that's happening now, basically. You can't just say it's changed in the past, therefore it's going to change in the future, without pointing to a cause.
Yeah, that's correct. The quick, second part answer too is that different causes of climate change have different fingerprints. So we're not just looking at global temperature. Once you break things down a little bit more, you can look at, okay, well, what's happening in the upper atmosphere? What's happening in the oceans? Is heat going into or out of? Some people say, oh, maybe ocean circulations are causing global warming, but we can look at the ocean and say heat is going into the ocean and not going out. We can look at the pattern of ocean warming. Is it warming in the subpolar regions and the tropical regions? And so different causes of warming would kind of have different fingerprints in the climate system.
Sure.
For example, the upper atmosphere, a region we call the stratosphere, is actually cooling, which we predict from rising CO2, but not, for example, from the sun. If the sun was getting brighter, the entire atmosphere would warm. So things like that.
Okay. What else? Any other compelling things where it's like, look at this, like, how could you ignore it?
Yeah. So humans we've actually put more carbon into the atmosphere than the entire biomass of the planet, in terms of, it's something like 2 trillion tons of carbon since the Industrial Revolution. And this is quite a lot. The one metric people have come up with is sort of an ice age unit. I don't know who came up with this originally, but if I guess, well, I'll ask you if you were to guess. So we talked about ice ages. So go back 20,000 years, and there's ice sheets over Manhattan, and the world's a very different places. We have woolly mammoths and stuff. But if you were to take one number, like a global average temperature, how much colder would you say that period was?
Global average climate difference. My guess is going to be. I'm going to go ahead and guess 8 degrees Celsius.
Okay, that's actually not too bad. A lot of people would say like.
A lot of people guess like 40 or 50 degrees. I know, but like, yeah. One frustrating argument is that people don't realize that like a 2 degree Celsius change in average surface temperatures. One, it's not evenly distributed, and two, even 2 degrees centigrade can be a really big difference depending on where you're at. Like it can move like your window of things outside of different things.
Yeah. So the current estimates are something like 5 degrees Celsius. And,
Gotcha.
You can roughly multiply these numbers by 2 to get Fahrenheit. So 9, 10 Fahrenheit. But and so we're talking. When people are saying, okay, in the future, in 2100 or 2200, a lot of people stop at 2100, but it's we're as close to 2100 as we are to World War II. It's not that far away.
Okay.
And so we could look past that as well. But people are talking about 2.5, 3.5 degrees, depending on the emission scenario primarily. But that's almost an ice age unit in the other direction. And if you're to go even farther into the future, 2200 or something, you can get 4 or 5 degrees. So it's sort of an ice age worth of climate change in the other direction, and it's not something we've seen for at least several million years. So I think when we talk about worrying about climate change, I don't like a lot of the existential threat narratives, like, okay, humans are going to go extinct, but if you turn the climate of New York into that of Georgia, or if you start to open up regions in the tropics that are uninhabitable because of heat stress, that's a big deal, and I think it's at least worthy of global attention. And you don't need you don't need a Mad Max world for people to start caring about it.
Gotcha. In your mind, what are some of the most annoying climate myths I guess you see posted online? Like you see something, you're like, this is so obviously fucking wrong or stupid, but you see it over and over again, and you think it's really pervasive in popular culture.
Oh yeah. There's so many of these zombie arguments that just don't die. One of the big ones that comes up, and actually this was just this guy, Steve Malloy, who kind of promotes weird stuff, but there's variability in global temperature. There's not a lot of it. It's if you were to think about the climate in New York City, you wouldn't say you wouldn't what's the climate during winter in New York City. You wouldn't just pick one winter. You'd pick 30 winters and average them together to kind of get, because there's a lot of variability in how warm or cold it is from year to year in a specific region. And that sort of noise decreases as you take a more global lens. So the global temperature has not as much variability as a city or a country, but there's still some variability. And so when people compare individual years, they're like, okay, 2015 was warmer than 2013, and that exercise is not too interesting because there's variability. But a lot of people, when you take a noisy data set so there's a trend plus variability, it's very easy to look at short-term trends, 3, 4, 5, 6, 7, 8 years, and draw conclusions about, okay, well, warming has paused or warming has accelerated. And statistically, it's just not a good use of anyone's time. So you really want to kind of keep an eye out on the longer-term trends, in which you start to see the signal of whatever you're interested in, say the CO2 forcing.
That was one of the things that kind of set off my bullshit alarm. Well, actually, because I do a lot of politics, there's a lot of things that set off my bullshit alarm. Like if somebody wants to make the argument that like Group A is worse than Group B, and you say, well, how do you know that? It's like, well, if you look at Group A, they actually do the most of this bad action from ages 27 to 36. And I'm like, anytime somebody cites something really specific like that, it makes me wonder if you're trying to generalize based off of like a very narrow choosing of numbers. And the Michael, I always want to call him Michael Fassbender, but I know that's not his name. The Michael, the climate change guy, when I was in the middle of that panel with him, and he said something like, oh, like it was like we had more heat waves, or our climate is the same now as it was in 1940 or whatever. That was like just such a strange, like, why would you measure to 1940? And I didn't even know in my head, like, oh, that was when the Dust Bowl was. Like, this is just not things that I have in my mind. And then I look it up and I say, oh, okay, well, this is why he's, comparing it to then when we were having like a whole climate catastrophe across the United States, funny enough.
It's kind of weird to be like, yeah, climate change is no big deal because it's about like it was during the Dust Bowl.
Yeah, with no Dust Bowl. Yeah, I know. Yeah, which is insane. Yeah, and I didn't even know that at the time, so I couldn't bring that up. I was like, why would you want that to be the norm? And the Dust Bowl was human driven, right? Like irresponsible agricultural practices and everything were, I think, a heavy driver in terms of a lot of the stuff that we were suffering. My understanding is across the United States, so it's kind of funny to compare it to that. Yeah.
Yeah, and actually, it's funny. I don't know if I'm able to share a screen or something, but it's if you were to look at a map of like temperature change over time, you would see like, or if you were to do a difference in temperature anomaly from like the 1930s to mid-century or to now or something, you'd see only in the United States pretty much is about as warm. And the United States is like 2% of the planet, so it's a small, but it's a very specific interval in the U.S. that so it's pretty hardcore cherry picking to just be like, okay, the 1930s in the U.S. is, but the point, the other point too is there's always going to be some period in the past, whether it's 1,000 years or 10,000 years, there's always going to be some period in the past where it's warmer or CO2 concentrations are higher or something like that.
Sure. Do you what's one or two other zombie arguments that you see that are brought up a ton you think are really dumb?
I guess another one is just thinking about, so when we talk about greenhouse gases, CO2 it's measured in parts per million. It's pretty dilute in the atmosphere. It's currently, if you take 1 million molecules out of the atmosphere right now, about, a little over 400 of them would be CO2. Mm-hmm. So it's not that many, but these things have a very disproportionate effect on Earth's temperature because of their ability to absorb infrared radiation. And if you were to take all the CO2 out of Earth's atmosphere, just a magic wand, take all the CO2 out of Earth's atmosphere, the planet would mostly freeze over. There's been some modeling studies that do this, and you end up with like a belt of water around the equator, but most of the planet is much, much colder. So it's like a very different Earth. It turns out Earth has always had some CO2 in the atmosphere, which is a good thing. It was something like 280. And the ice age cycles, it goes from something like 180 to 280 parts per million, and now, like within a century, it's at 420 now.
Have you seen Have you seen the dots?
The dots? I don't know.
The dots. Fuck me, dude. This is just so stupid. There's a guy that showed me a picture, and I guess I've seen a couple of people pass this around now. There's a picture, and I'm seeing someone in chat is gonna link it. There's a picture, and it shows like, I think 100 dots, and it's like, this is how much CO2 was in the atmosphere, and only 2 dots are selected.
Oh, I see.
Yeah, and then it does another one. It's like, now it's 3 dots. Like, are you telling me this is a big deal? It was just like one of the dumbest fucking. I didn't know how popular it was in climate change. Yeah.
I've seen many things like that. Yeah, it's also silly because the other molecules. So most of the atmosphere is nitrogen and oxygen, and those molecules. They don't absorb infrared radiation, so it doesn't actually even really matter. Well, it does. This is a technical thing. It would matter if there was like double the nitrogen in the atmosphere, the planet would get warmer. But that's primarily through its effect on there's something called pressure broadening, which is like how the amount of atmospheric pressure there is affects the ability of the other gases to absorb radiation. But if you were to, but that's kind of an indirect effect on the other gases. But if you were to take that part of the equation out, just adding nitrogen to the atmosphere wouldn't do too much.
Sure.
So it doesn't really matter how many dots there are on that kind of graph relative to the other molecules, because it's the water vapor, it's the CO2 that's absorbing the infrared radiation, and there's a lot of it in the atmosphere.
Yeah. Can I wait? I'm sorry, real quick. 'Cause somebody in chat just said something, and then you can speak on this too. Somebody said, "Do you remember when there was the ozone and it was depleting and then it regenerated? They said it will never come back." So that didn't happen by chance or accident. I'm pretty sure that was because we took really aggressive actions across the entire planet to reduce certain types of aerosols or products we were using that were, yeah, go ahead.
No, exactly. Yeah. So we had this, the Montreal Protocol, which put a limit or a ban on the chlorofluorocarbons. I can never say that, CFCs that actually deplete ozone. So that was an example of something where it's kind of small compared to the climate change problem, which I guess I'll get into in a moment. But that was an example of where scientists saw an issue. There was kind of theoretical work around, why it was happening. Some of the science was wrong initially because they weren't thinking about a certain type of cloud in the polar regions that affects the chemical reactions. But eventually this stuff got figured out. Montreal Protocol, was put in place, and all of a sudden, voila, the ozone layer started healing. But if you were to run the world forward with no Montreal Protocol, there's quite an increase in UV radiation, skin damage, and stuff. It's not a huge climate impact, but the UV radiation is important for many other reasons. So yeah, I always find it weird when people use the wrong predictions of the ozone hole to kind of cast doubt on things, because it wasn't wrong at all. It's just we actually did something about it.
In terms of messaging from climate scientists, what do you think are some of the biggest missteps that they make when it comes to speaking about climate science? Like, what are some ways that you think the message could change, or what are some messages where you're like, fuck, like I wish Al Gore hadn't had made that documentary, or people hadn't talked about like the dying dolphins or polar bears or whatever the fuck. Yeah, go.
Yeah, definitely. I think so. There was a period of time where I think a lot of people who actually work in climate don't tend to be the ones who are talking about everyone's going to die and the polar bears and stuff. But still, we can, because we're scientists and we have kind of personality. People can get very robotic about things like, oh, the IPCC says the globe's going to warm 2.5 to 5 degrees, whatever. And it's kind of repeating these facts that don't make contact with a lot of people's intuition. And so I think it's good to have communicators who can sort of engage with farmers about, agricultural yields, or put things into a perspective like, okay, well, Chicago has X number of days above 90 degrees Fahrenheit every summer. Now it's going to be, 4 times that, right? And so that just helps people's intuition rather than just kind of giving some bullet points about, this is what the IPCC said will happen by 2100. So there's good science communicators who are much better with doing visualization and more down to the earth facts about what climate change actually means for the average person.
Speaking of, when you say science communicators, how do you feel about like pop science communicators, so like Neil deGrasse Tyson or Bill Nye? Do you think these guys are largely effective or ineffective, or?
I like them. I think they're a net positive. I don't always, even if I disagree with things they say, sometimes I like Neil a little bit better than Bill if we're getting very specific, but it's not too important. I think they do a good job of not just on climate, but Neil of course talks mainly about astrophysics, and will do a lot of things about debunking myths around astrology, for example, or talking about how things work.
Astrology, astronomy, right?
I meant astrology
Oh,
when I said talking about, well, myths. The entire thing's a myth, but talking about why. So I think engagement like that
okay.
is good. So I think they do a net positive. When it comes to more of the political like stuff, well, I guess Al Gore did good with bringing things kind of to the front and center on people's minds. I tend to cringe a lot about the actual material though when it comes to, especially in recent years where it tends to be more of a do I want to bring kids into this world? Is the planet fucked? Just kind of, I get asked that a lot if I tell people what I do at a bar or something. Like one of the first questions is like, are we fucked? Like, is that, and it's very hard for me to like process that question because I don't really know what to do with it. It's just kind of like, well, it's okay, but
This could be better, yeah.
have your kids. It's okay. Could
It
be
sucks
better.
when people make problems seem intractable because then it's like no one's going to do anything, right?
Yeah, I wouldn't put it, so climate change I view as a big deal. I wouldn't put it on, like, if I was to have a list of a couple things, I don't know what your list would be of like existential, like actual, like things that would cause humanity to go extinct or close to it, or something that would completely radicalize or radically change like what human civilization looks like. I wouldn't put I don't put climate change in the top few. I would nuclear war could be one example. Um, Maybe another a pandemic, something that was you can imagine if COVID was like 100 times more deadly or
Or even
more
10 times more deadly or
transmissible.
something would have been
Yeah,
insane. Yeah, sure.
that's a pretty big deal. So, but I do think it's something. Climate change is also unique in that it's not a local problem. It's and carbon emissions. One of this guy Raymond Peter Humbert called it humanity's final exam because of the global nature of the problem. Because no individual country's emissions they matter, but they're not enough to kind of
If
stabilize
we're not
global
all working
temperature.
together,
And
then you kind of get it doesn't really work well, right? Yeah.
yeah, because of the well, there's a few properties of carbon emissions that maybe a lot of people don't know about. I mean, one is it doesn't really matter who's emitting the carbon. The CO2 is very well mixed in the atmosphere, and so it doesn't matter if you're emitting it in Europe or in Australia. That atmospheric CO2 is going to be known by the planet, very quickly. Um, the other thing is it's not directly the carbon emission. It's the total. It's the cumulative carbon emissions that matter for climate because of CO2's lifetime in the atmosphere. So all the carbon that's emitted since the Industrial Revolution, that the climate knows about. So unlike say methane, for example, like some short-lived things like methane or aerosol pollution from factories, that stuff has time scales of weeks to years in the atmosphere. So if for methane, if you just kind of slow emissions down, then you see a drop in the atmospheric concentration. With CO2, you can't just stop it. You can't just slow emissions or stabilize emissions. You have to bring emissions to essentially close to zero to stabilize the global temperature. And so that's a very hard problem to say. Okay, we can't just stabilize global carbon emissions. We have to bring them to reduced 80% or 100%.
Sure.
That's a much harder problem.
What did you say? What was your specific area of study again?
So I started in Earth atmospheric science. So my PhD was like in how volcanic eruptions influence rainfall. But then when I got my postdoc, I went more into a planetary direction,
Okay.
more modeling and theory of so exoplanets and just kind of idealized questions. What happens if you change the rotation rate of the planet or the tilt of the planet? Those kind of questions.
Gotcha.
Um,
Does this bring you in line
Also,
ever with any like modern, like what's better, like solar versus nuclear? Like, do you engage with those questions at all, or are you more like on the very pure, like kind of theoretical side of like when these grand things happen to planets, this is how it impacts their climate. Not to, it
Yeah,
sounded like I was attacking the theory side. I'm not meaning to do that, but yeah, I'm just curious where you're like.
no, I know what you
Yeah.
mean.
Uh-huh.
Yeah, yeah, definitely like things like alternative energies are outside my comfort zone. I'm not going to speak too much on that just because, yeah, I don't tend to get too wrapped up on this. I will say though that, you know, I think in your email you asked me about this. I don't have any. You know, a lot of people have strong opinions about say nuclear. I don't.
Mm-hmm.
I don't know enough about it either. But from what I understand. Solar and wind have, I mean, the price has decreased by an order of magnitude in the last decade, and in some cases are now cheaper than natural gas. So I don't know that there's a financial challenge there with. If you were to, you wouldn't make a grid just on solar or just on wind, but in terms of combining these in an optimal way, geothermal, nuclear, wind, solar.
Mm-hmm.
Natural gas if needed, but I don't know that there's actually a financial reason why this can't be done. In a lot of countries, I think last I looked, it was like 35, 36 countries have, one of the arguments made by, let's say the Jordan Petersons and the Michael Schellenbergers and those people, Bjorn Lomborg, one of the arguments they make is that, well, look, if you look in the last century, um, the fossil fuel era has also coincided with great economic growth, great economic prosperity, and longer lifetimes and all that, which is true.
Yeah.
But ultimately, what people need is energy. They don't need fossil fuels specifically, and a lot of countries have now decoupled their GDP growth from their carbon emissions.
Mm-hmm.
Uh, so yeah, I think moving forward, and fossil fuels have all kinds of their own problems. Of course, it's a global, the prices are set globally by things like the Ukraine war, which is a limitation.
Mm-hmm. What do you think are like some of the like a few? I understand you're not like as much on like the policy or econ side of things, but like broadly speaking, like what do you think are a couple of big things that we should be pushing for to like dramatically change, I guess, like the course of the amount of carbon in the atmosphere going forward? Like, so for instance, you mentioned earlier something about like not flying isn't going to change things much or something. What are like, yeah, what are like the big things you think people should be pushing on more or leaning into?
So one of the, I guess, good things that has come out of these called NDCs, the nationally determined contributions from, so we had the Paris Agreement and then recently had the Glasgow, the COP26 meeting, where every country is making certain pledges, and most emissions come from industry, from producing energy, from transportation also matters.
Mm-hmm.
I think one thing that's hard with climate communication, that there was a period of time, I think, where people were very much talking about individual action, what light bulbs to have, and how to reduce your carbon footprint. I think there's room for this kind of messaging, but really, the big picture problem is the global energy system and fossil fuel companies and how humans get our energy. That's kind of the big thing. And so I hate to say, okay, what you do doesn't matter, but we do need a systemic global change in terms of, I hate to abuse these words about systemic change and overthrow everything. I'm not one of those people, but we do actually need like a completely different way to get energy at the global scale.
Gotcha.
Now, and there's, people are skeptical of the commitments that have been made. So I think the U.S. and European Union have pledged to reach people use this term now, net zero greenhouse gas emissions by 2050. China's pledged by, I think it's 2060. India recently committed to reach net zero by 2070. This stuff is very, not too binding, especially, and people who work in this kind of group things by near-term pledges to 2030 and then like pledges afterward. And and also kind of business as usual policy. But these pledges that countries are making, if you were to take them at face value, they have a big impact on the future of the climate in the next century. The estimates could be, I think 1.5 degrees is out of the question at this point. There is a world where we can, if every country, quite literally reach their pledges to reduce carbon by X amount, according to their own contributions, by 2030, and then after that, there is a world where you can hold off 2 degrees, but then after that, and it depends a little bit on their, you know, what they're promising, and but there's a world where you can have a 1 degree spread, just how they sorry, I can't talk right now, but
No, you're good.
based on like their contribution history, their contributions, and how close they match to their current pledges. And these pledges are meant to sort of ratchet up with time and get more aggressive, but and there still remains a large disconnect between the modest near term, like 2030 commitments, and very ambitious 2050, 2070 commitments.
Gotcha.
So I think 1.5 degrees is out of the question now. You have to basically like have our global emissions in the next 5 to 10 years. 2 degrees is plausible, but one of the good news is that some of the worst case carbon emission storylines no longer seem that plausible. So if you were to talk to most people like 10 years ago, I think the use of coal has started to level off. I think there was hope that global carbon emissions might peak in 2019 or something before COVID. That doesn't seem to be the case. It seems after COVID they've bumped back up to pre-pandemic levels and exceeded it. But coal emissions have stabilized, and we're now, the price for wind, solar, batteries have decreased quite a bit. So if you look at, say, the scenarios that were used in the last couple IPCC reports, and of course, so there's a couple different sources of uncertainty. One is just the climate uncertainty, but one is the emission. That's a social uncertainty, and that really dominates a lot of the picture going to the next century. So the last IPCC report would use these RCP scenarios, and this got replaced but they're essentially concentration pathways that now look based on if you were to take these new pledges and the new trends in coal use, it doesn't look like the worst case emission timelines are plausible anymore, which is good. So now we're talking more 2 to 3 degrees instead of 3 to 4 degrees or something.
Do you have
But
or no, go ahead, finish your thing.
Yeah, but I was going to say also, there's a lot of ambiguity in those targets because of things like non-CO2 effects with aerosols or with methane. There's ambiguity with carbon cycle feedbacks in the Earth system, and then the other thing is a lot of these net zero concepts allow for positive emissions, but in theory offset by negative emissions in the future from, say, carbon capture that aren't really tested at this point. So there is potential for misuse with these things. I'm a little bit, I guess, to summarize, I'm a little bit of a pessimist, but it looks like the most extreme emission stories won't come out to bear.
Are you so I'm sorry, because my chat keeps asking. Do you feel strongly about geoengineering? Is what they're saying. So I guess this is like adding things to the atmosphere or whatever to try to control climate that way. Yeah.
Feel very strongly about it. I think it's a disaster. No. So one of when people say geoengineering, they often mean different things, but one of the most popular forms is what's called solar radiation management, which is essentially mimicking a volcanic eruption. So we know like a volcano can go off. The last There actually was a recent big one, but the last, like, I would say, big one for climate was in 1991. It was Mount Pinatubo, which released a lot of the sulfuric acid, which converts to sulfate aerosols in the upper atmosphere, and that scatters sunlight and that cools the planet a little bit. So the idea of geoengineering is that there's a few problems. One, I think, one of the big ones is the time scale of the aerosols and the CO2 in the atmosphere are completely different. So CO2, when you emit CO2 in the atmosphere and change the concentration, it's going to stay like this for thousands of years. There's a tail of the CO2 that lasts tens to hundreds of thousands of years. So if you stop emitting CO2 right now, you don't have a pre-industrial CO2 atmosphere
For like
in a few
millions of years
weeks.
or something. Yeah. You mentioned before
Yeah.
that like things like methane and stuff clear out very quickly, but the CO2 will hang around for a long time.
Yeah, and the aerosols are in the short-lived category where, let's say in 2070, people decide to stop, this geoengineering project. Well, now your aerosols go away and your CO2 has accumulated, and so you get a sudden burst of warming that's quite pronounced. It also doesn't address some other issues like ocean acidification, which has to do with the reduced pH in the ocean from the carbon uptake. And then there's all sorts of moral and policy questions of like who controls the thermostat. It's like who controls the aerosol emissions. You also, it's just from a physics standpoint, it's really impossible to keep the global temperature and regional temperature and precipitation kind of self-consistently at pre-industrial levels, right? So you can make the global temperature cooler with aerosols, but you're going to affect rainfall in certain regions. You're gonna, if you, for example, if you put these aerosols mostly in the northern hemisphere, you're going to have a hemispheric temperature gradient, and you'll have a belt of tropical rainfall that sort of moves southward a little bit, things like that. So now a country has a drought maybe because of this. It doesn't even need to be certain that it was because of this, but they can start to blame another country. Hey, you caused our drought, what's going on here?
Gotcha. Do you,
So I see all sorts of problems with this idea.
Sure. Yeah, I guess it's like monetary policy, except for the atmosphere. So yeah, it's a lot to give up. Do you have any strong feelings about carbon capture technology? I hear this talked about sometimes.
I don't know much about it other than it's not at scale yet to where, climate people aren't too, like when we talk about the CO2 concentration at the atmosphere being 420 ppm, there's no credible way right now to bring that down to something like pre-industrial concentrations. That's as much as I'll say about it. I don't know too much about that technology. In principle, that it sounds good. There's interesting climate questions about reversibility if you were to just suddenly take CO2 down to what it was in 1950 or 1900. You do remove a lot of the warming signal, but there's still slow components of say sea level rise that are still they have a lagged effect. So
Gotcha. Okay. Well, yeah. Is there anything else you want to go over or talk about?
not at the moment. Yeah. So this was fun. I just had to touch base and.
Do you ever thought about doing like formal conversations or debates or whatever with people online over climate related stuff?
I would if it would depend on the person. I think there's different categories of people who are worth or not worth engaging with. I think a lot of people are. I know this is kind of what you do for a living is debate people.
Yeah.
I enjoy debates, especially on cultural issues and philosophical issues. And when it comes to technical matters like science, though, like I don't. It's a little awkward because so much of it is who's the best rhetorician in a given panel or something, who can speak the loudest. And I think there's a lot of people who are very like if you felt strongly about your position, you would debate it and that kind of thing. And I am more willing to do that than a lot of people just because of my personality. But I also find debating like physics to be strange because there's just a lot of technicalities that you can't like look up on the fly. You can't verify it in the moment. But anyway, yeah, I would talk with certain people. I think that there's, people who are like the greenhouse effect doesn't exist. It's just not a good use of time.
Gotcha.
People who have more nuanced positions about, the severity of things, or I would talk with these people definitely. If you ever need to give me a ring, to show up on some panel or something,
Yeah, sure.
I would contribute.
Yeah, I think unfortunately, the arguments still have to be made for the greenhouse stuff because a lot of people just don't believe in it. But I do agree that, like, in my opinion, the really interesting conversation is past the climate side. I think the interesting conversation is on the economic policy side. Like, how much of our standard of living should we be expected to give up for certain types of compromises that we could make with like atmospheric emissions, or like how much is it fair that developed countries are expected to cut emissions so much more, whereas developing countries like India and China can still pollute so much more than we're allowed to. I think those are the interesting conversations, but we can't really get there when I think at least the United States still doesn't even believe it's a real thing. So, yeah.
I'm actually looking at your chat on the YouTube. I'm already seeing people are like, "Oh, it's interesting. He's afraid to debate." And
Oh, that my
a lot
YouTube
of-
chat is because when I talk to my YouTube
there's-
chat has a lot of conservatives in it. So yeah.
There's a lot of opinions about who I should be debating. So I don't know these people, but anyway.
Yeah, it's also hard too
I-
because
I-
like when it comes to a lot of these types of debates, it's sometimes it can get to very, very, very like esoteric knowledge about certain mechanisms, and like if you're not prepared for every single point, you just kind of look like a loser. I feel okay with my physics knowledge, but like I would always lose a debate against the world's best flat earther just because they would bring up some very weird phenomena that I wouldn't have an answer to, and then it's like, well, fuck me, I guess I can't respond to this,
It's weird, like, especially, yeah. So flat Earth and like creationism is examples of this, where people are like, oh, look at this thing that someone calculated the moon had to be this old from these calculations, and you're like, I don't know who made those calculations. I'm sure they're garbage, but like I can't
exactly,
like, prove it to you in person, So
or somebody will expect you to walk through exactly like, well, radiocarbon dating is just they set a random year and now they all agree with it. Like, how can you prove that? How can you prove that it is as old as you think it is? And it's like, well, it decays at like a certain rate. It's like, well, that rate changes over time, and it's like, I don't think that's true, but I don't know that. Like, I can't fucking and then just like fuck that. It's like, okay, yeah, but what are you gonna do? Yeah, okay.
This was fun.
All right. Well, hey, if anything ever comes up, or if you hear anything or see anything, or if you want me to moderate a conversation or anything like that, yeah, feel free to reach out and shoot me a message. And yeah.
Sure. I guess we could chat about other things, I also have an interest in relationships, and I play poker, like, just all kinds of like obscure things. But yeah, we'll touch base, I guess.
Yeah, sure. Shoot me a message. Just let me know. Yeah.
All right. Yeah. Thanks for your time.
Yeah. See you later. Bye. Wait, real quick. If people want to look for anything of you, do you have like a Twitter or anything? Or
It's at CColose. That's CCOLOSE.
CCOLOSE. Let me just make sure that's right. Yeah. Okay. Cool. All right. Well, hey, thanks a lot. I appreciate the conversation. Have a good one.
Have a good one.
Bye.